All right, number 8, we want to consider the following relation, and we have 3 parts. First part wants us to rewrite the relation as a function of x. Okay, so what that means is we just basically want to get it into y equals format, and we're going to replace the y equals with f of x. So the relation we have is 4x squared minus 3y equals negative x plus 2y. All right, so we're going to get the y's, collect them together on the same side, so I'm going to move them to the left. It doesn't really matter, but we traditionally put y on the left-hand side. So I'm going to subtract 2y from both sides. Bring down the 4x squared. This will be a minus 5y now, equals negative x. I'm now going to move the 4x over by subtracting 4x squared from both sides. That will go to 0. Bring down the negative 5y equals negative 4x squared minus x. And then we're going to divide by negative 5. And that will leave us with y equals, we'll just say this is a positive 4 over 5x squared. And then this will be plus 1 over 5x. Now you can put the x to the side or on top, it doesn't matter, it's the same. Negative divided by negative is a positive, that's why we change the signs. And then this is just equation format. The function format, we just replace that with f of x, and it's the same thing, 4 over 5 x squared plus 1 over 5x. Over 5x squared plus, I guess I gotta do the division bar first, 1 over 5x. This should give us part 1. Okay, now part 2, we want to evaluate the function found in the previous step at negative 3. Okay, so this time, and all you want to know is that whenever you want to evaluate, you're just going to be replacing x with whatever number. So here we're going to be, everywhere we have an x, plug in a negative 3. All right, so we're going to do 3 squared is 9. 9 times 4 is 36. So we have 36 over 5. And then negative 3 times 1 is negative 3. So I can just say minus 3 over 5. Common denominator, we can just add or subtract the numerators, and that will give us 33 over 5. So we get an ordered pair. X was negative 3. The end result, the y value that we got, was 33 over 5. This is how that works. So we get 33 over 5. And then part 3, determine the implied domain. Okay, so the implied domain that we would get, if you refer back to, I can't remember what example it was, but I went over those 3 scenarios that you look for. So here is the function that we have. I'll look and see, do I have any variables in the denominator? No. Do I have any radical square roots of even degree? No, we don't. Do I have a logarithm? No. So that means any number we plug in will work. So your domain will be all real numbers. They want it in interval notation. So we have no restriction, so that means all real numbers. All right, number 9, we're going to be doing the same thing with this new expression. We have negative 5y plus the square root of x is equal to 2x plus x squared. All right, so to solve this, we are going to move the x squared over. So we're going to subtract x squared. Oh, so not x squared, the square root of x. Subtract the square root of x. I'm going to rearrange this and put it in order from descending to largest. So negative 5y equals, I'm going to put the x squared up front, and then plus 2x, and then minus square root of x. And then we're going to divide everything by negative 5. And I'm going to write this one a little bit more simple this time. I'm just going to put all over 1 negative 5. So y equals x squared plus 2x minus the square root of x all over 5. Now I'll put the negative out front. So this is what we get with our expression. And then again, the y and the f of x are the same. So I'm going to put a negative, division bar, and then x squared. If you push shift 6, that will do the upper, the variable for you. Plus 2x, and then minus, I guess I got to do the keypad. I can't do a shortcut for square root. X over 5. Okay. So I guess they don't like that format. So we're going to just do it without, unless I missed there was a cube root right there. I didn't notice that if that was the case. So let's try that one again. 2y plus cube root of x, 3x plus x squared. So I'm going to subtract and move that over. It's going to give me 2y equals x squared plus 3x minus the cube root of x, and then we're going to divide by 2, and so we have y equals x squared plus 3x minus the cube root of x, all divided by 2. Let's see if that might have been it. I'm running out of room there. X squared plus 3x minus, uh-oh, how did I get to the bottom? Minus cube root of x all divided by 2. And then of course they might want you to write it all separate. Yep, it's fine. Maybe it was a cube root. This time we want to evaluate with the negative x, so this is why I left it as one fraction, so I can just deal with the top and divide by 2 at the end. So negative 8. So we're going to be doing f of negative 8, negative 8 squared plus 3 times negative 8 minus the cube root of negative 8, all divided by 2. So this will give us 64. That will subtract 24. And then this will give you a negative 2 when you do the cube root of 8. Negative 2 minus a negative 2 will become plus 2. This is all divided by 2. That will give you 42 over 2, which equals 21. So we just get 21 there. And then part C, the implied domain. Okay, so again, if we go through those checklists, we're looking for, do we have a variable in the bottom? Okay, we don't have a variable in the bottom, just a number, so no restrictions there. Do we have an even root? So we do have a cube root. That's an odd degree. I have to go back and remember that exception. Odd works. We can have a negative under odd. As you see, I evaluated this one. Also, if you're not familiar with cube roots, on calculator, what it's looking for is what you multiply it times itself 3 times. So if you do math and you arrow down option number 4, or you can just hit number 4, and then I type negative 8, okay, it will give me 2, because negative 2 times negative 2 times negative 2 gives you negative 8. You can have 3 negatives and get a negative. So if you're not familiar with that part or that rule, then you can have a negative under an odd radical. So there's not a restriction here. Even though we have the root, you got to remember it has to be even. So just a regular root, or 2, 4, 6, or something like that. The regular root is 2. Sorry, that's the basic one. So no restrictions there, and then we don't have any logs. So your domain is going to be all real numbers. Again, in interval notation, go ahead and use the keypad, parentheses, negative infinity to infinity.